Okay, so I'm going to talk today about a new topic, maybe for you. It's called accountable AI agents and how we build them with AllegroGraph. Now, our company, Franz Inc., makes this product, AllegroGraph, and we use that to build knowledge graphs, right? So we're a typical knowledge graph company. We come in, we help big customers to that already tried 4 or 5 times to integrate all the data, and it didn't really work. And they think, you know what, let's try it with the knowledge graph. And so we come in. Nowadays, there's already a team of ontologists in big companies, and we basically map their input data into a knowledge graph with the hope that your data gets 100 times easier to work with, right? But then you still have static data. So for us, the fun starts when we can start adding AI to these knowledge graphs, right? So for a long time, we've been adding logic, machine learning, and LLMs, right, in the mix. And we call that combination of AI Neuro-Symbolic AI. So again, I've explained this to lots of people, right? Like 15 years ago when we started, it was all about ontologies, taxonomies, description logics. But description logic is not that powerful if you want to talk about space and time. So we added a full Prolog compiler to our toolkit. And so now we can write any rule-based system on top of a knowledge graph if you want to. And then 10 years ago, we got deep into doing event-based knowledge graphs, where we, for example, store a patient as a series of event or a plane as a series of event. And of course, the most natural thing then is, hey, can I predict what's going to happen next, right? So we started adding graph neural networks and recurrent neural networks to our toolkit. So now we can predict events. And then 3 years ago, our world completely exploded with the arrival of LLMs. And for the last 3 years, we've been working really hard to make LLMs an integral core of AllegroGraph. So you can, in Sparkle, our query language, talk to LLMs. We have a full vector store inside, so we can do GraphReg. And we can now do natural language queries directly in our product. So that is a little bit about what we've done so far. And this combination of AI technologies called Neuro-Symbolic computing, and it's for the last several years been high on the list of Gartner. And if you look at the recent Gartner reports, then our company sits between IBM and DeepMind as one of the companies that actually provides all these different types of AI in one framework. But our world changed again. And now we suddenly have to talk about agents, right? Everywhere where you go, it's agent, and agentic AI. So I'm going to talk a little bit about agents and about the fact that we now have also an AllegroGraph MCP. But more importantly, I'm going to talk about if you have accountable agents, if you have autonomous agents, right? How do you make sure that they do the right thing at the right time and you can check on their behavior? So I'm going to talk about that too. So first, people might think, oh, so Franz is jumping on the agent bandwagon, but 25 years ago, I worked in telecom, and I was already managing several projects where we built agents, and I actually have a number of patents. This is no hallucination. I have a number of patents in the area of agent and agentic system, because even 25 years ago, it was already kind of possible. It was mostly about the interaction between agents, but it was absolutely not the fun that we have now with agents, right? I mean, at the time, it was all really painful rule-based systems to get things to work. Now it's just an amazing way to deal with agents. So, I'm happy we finally, the whole thing came back again. And right now, as a company, we're making money primarily with building agents for customers. I'm going to talk a little bit about the project we do for a company called SIB, where we match invoices with contracts using all kinds of agents. And we build a framework for a big enterprise and governments, right, where we have autonomous agents. So let me first talk about one agent project that we do. So we have this company, SIB, and what this company does, it takes care of invoices for companies, and it negotiates new contracts with vendors for companies, right? So basically, they say, hey, give me all your invoices, all your contracts. We'll check if every line in your invoices is correct, because you have to remember, or you probably don't know, but 40% of all invoices have errors. And for some mysterious reason, usually to the advantage of the vendor. Not always, but usually, right? So we can check every line in an invoice to see if it's correct with respect to the contract. And we build a whole system around it. But if I want to summarize it, say you have a company that has an invoice from AmeriGas, right, with a number of line items. And then we have a contract or an amendment to the contract. So what we do, we take we use advanced LLM technology to using a combination of LLMs to take invoices apart into the smallest part and put them into our knowledge graph. We do the same thing for the contract. And then what we do is we find the anomalies between the invoice and the amendment. So this is what we do in a UI that I'm not going to show today, although contact us if you have a full demo of this system. But basically, what we showed in the UI, that there's two line items that are not correct with respect to the amendment. And then and what you can also see is that we actually use multiple LLMs to check whether or not these invoices are correct. If both LLMs agree, we don't do anything, we just put it in the UI. If they disagree, then we have a third LLM to figure out, okay, which LLM was actually right? Beautiful project, but it's entirely agent driven. So we have an invoice agent that goes out and sees whether there's new invoices for a particular customer. And then if it sees one, it puts it into AllegroGraph. There's a contract, if there's a new contract, then the contract agent will take the contract apart. And then very important, we have this thing called an anomaly agent, that every time when there is something changing in the knowledge graph with respect to a new agent or a new contract, it will start doing its work to look at all the anomalies. And anomalies are not only about whether a fee is allowed, but also whether the increase in the price was higher than the inflation correction, or whether there's a fee that happens only once in 10 times, right? Anyway, there's a whole lot of, we have like a whole library of anomalies that can happen in invoices. And then, so this is all functional in production. And we're now working on vendor agents where when there's problems with the invoices, we actually can completely automatically send emails to the vendor to try to fix it, right? And we also represent the client, so we can also take care of the client. And sometimes we go out to the internet to find with the research agent, okay, what is the tax in this particular city, right? In this county and in this state. So a lot of work is happening. And each of these agents are truly independent and all orchestrated by AllegroGraph in the middle. And then a second project that we work on together with Tom Sawyer is an agent framework for a big enterprise where an analyst can talk to a whole series of databases and knowledge graphs to figure out things about an individual company or an individual organization. And the context is, so in this big enterprise, there's probably 50 databases that are important to the analyst. And the company at the big enterprise already for 5 times has tried to integrate all the data and has given up, right? Because it's just too complicated and too big. And there's no political will anymore to kind of integrate all these databases, but we still need to talk to all these 50 databases, right? And so now we have a new system that is entirely agentic, where every agent is a specialist with MCP capabilities. So agents are specialized. So an agent is specialized for a particular database, right? Whether it's SQL, NoSQL, or graph, or it also specialized for a particular person that you might be interested in, or an organization. Usually when you say, hey, give me everything about this person or this organization, you get a massive process through all these databases to figure out what do I know about this person. But if you have an agent for a particular person, then that agent independently can go out hunting for information about itself or the person that it stands for and build up a knowledge graph just for that, a 360 with that person or for that organization. Very important is also that every agent has an ontology of the database, and if you, and I'm going to demo that in a few minutes, for fairly simple structured databases, it's fairly easy to do query generation, right? But most databases are really complicated, and you have to train the LLMs by creating hundreds of successful queries that we store in a query library. And so that if you want to create complicated queries, you actually can look at examples in the query library to figure out, okay, what is my query going to be? Then also we found that you might have to write tutorials. So for example, we have tutorials for how to use free text indexing in various databases, or how to use vector stores and how to deal with that in your queries. Or if you say a particular healthcare database, then there's so many ins and outs for a healthcare compared to, say, an enterprise database, that you actually have to write tutorials, right, that the agent can read while it's doing its work, so that it's easier to create the right query and get the right data back. Then you can give these agents tasks just by giving it a structured text, right, regular queries, or you give it NLP instructions. And each agent itself can have a small or big knowledge graph that holds every action, every decision, and that you do that for accountability reasons, right? You want to know, and I'm going to talk more about what I mean by accountability. And then at the heart of it sits an orchestrating knowledge graph, AllegroGraph, that knows the skills of every agent and the ontology of every agent, sorry, it has to say the ontology of every repository. Sorry, I made a mistake here, right? So when it gets a big question in, it knows what agents to ask to do something or what repository we might need, right? And so then it gets a challenge, it breaks down the task into subtasks, and it has a complete history of every action and decision, again, for accountability reasons. But so I've been looking at agents for a while now, and I get kind of confused, and if I'm honest, actually irritated when in a conversation with people and we talk about agents, because there's actually so many types of agents, and people usually don't even realize what kind of agent they're talking about, or they have no clue that there are also other agents, right? So about a few days ago, I wrote an article, The Rise of Accountable Agents, How Knowledge Graphs Solve the Autonomy Problem. But it's also about the fact that there's kind of three competing visions of AI agents. When I talk to CEO friends of mine, then they don't even know about MCP or autonomous agents, right? All they think about is, okay, it's almost like a RPA. How can I make my processes more efficient? How can I get rid of people by letting LLM do certain things? And but it's more about how can I streamline my processes and make my processing cheaper? It's not about, right? So there's some people, business people you talk, they have no clue about agents, right? And then there's this developer agents, that is the MCP. Now, don't get me wrong, I love MCP. I work a lot with it, but it is just a bridge between an LLM and external systems, right? And in my article, I write that while powerful, calling these interfaces agents stretches the definition beyond recognition, right? It's like calling a keyboard an author because it enables writing, right? So anyway, we call it Agentic AI, and MCP helps with that, but it's not really agents. If I talk about agents, I really, really want to talk about autonomous systems, right? And that's Gartner and Forrester write all about it. They want to look into the future. However, there's hardly any real system yet that do autonomous agents. But I'm going to talk a little bit about the MCP and about true autonomous systems. So let's begin with the MCP, right? So I don't know if there's any cognitive psychologists or philosophers in our audience, right? But maybe you know this whole thing about the brain in a fat theory, right? So when I started looking at MCP, or LLMs in general, I started thinking about maybe we are all in a big lab, right? And we're just a brain in a fat, and we all think that we're real, right? But anyway, I looked at these LLMs, and they're trained, but then they couldn't talk to the rest of the world. You just could only ask a question and you got an answer back, but they would say, I'm trained up till April last year, right? And there was nothing they could do. But then after 2024, when Anthropic published the MCP standard, right? Suddenly the brain in the fat has ears and eyes and can change the world, right? So this is for me the metaphor about MCP. And if you want to go a little bit more technical, MCP allows AI agents to access real-time data, invoke external tools, and orchestrate complex workflows. And I just looked up, there's now about 20 to 50,000 servers, right, that people host somewhere that you can talk to. And so basically there's an LLM here, right? Then there is a server, a bridge in the middle, one that, for example, lets you talk to your Gmail, right? So there's an MCP agent for your Gmail, but there's also one to talk to an Oracle database. And it makes it easier for people to, instead of you having to write a whole series of tools to talk to an Oracle database, you can just go to the server, right, to talk to an Oracle database. And it makes life very, very easy. And you can talk to almost any kind of application right now. So AGraph MCP. So we created also just as a demo, an AllegroGraph MCP where it can talk to all the database, all the repositories that you might have in your server. In order to create queries, it needs to do schema introspection, right? So for SQL, it would be introspection from the schema in Sparkle, or for the AllegroGraph, you need to get the shackle, to think of like a schema language, right? And then we generate queries, and when we have a successful query, we store it in a query library. And then in the future, when you do more queries, we actually also look for successful examples, because in addition to having the schema, it also really helpful for MCP to look at successful queries in the past. And then our MCP can also deal with the fact that we have a vector store in the product, so it can actually do very advanced stuff with looking in text in a knowledge graph, or it can use regular good old-fashioned free text indexing. And once you have Sparkle queries, you can also do visualizations and federated queries. So I'm going to take a plunge and see if Claude is fast enough this morning. Otherwise, I'll do a little video, but it's more fun to do it real. Okay, so I can say, so I set my active repository to Northwind Traders, right? And I can say, please show me successful queries in a table. Show me increasing number, the URI, and the title of the query, right? And it goes off. If it goes too slow, I'll go to the video that I made. But let's see if we can wait for a second. So basically, it's calling tools, right? So there's a tool list all queries that it now calls, and then it thinks, okay, what do I do with this, right? And then it says, oh, here are 33 successful queries for the Northwind Traders repository. And actually, I'm sorry, let me first, so here's all these queries, right? Well, let me show you something. So we have an AllegroGraph query browser. So I have like a customer retention and segmentation analysis, or customer segmentation analysis over the Northwind Traders database here. And so here you see a Sparkle query. Now in this entire database of queries, 33 queries, there's not a single query that I wrote by hand. It's entirely written by Claude, right? And it also did the visualization. So I can look at the visualization. And do you see the bubble chart here, Janet?
Yes.
Okay, so let's see here, right? And so I can keep going, discount versus quantity scatter plot data, right? Again, it stored the description of the query. Very important, because we also put this in the vector store. So when we look for successful queries and you have the 500 of them, like we have in the SIP project, then you can't read them all in MCP. That would already flood your context. So what we do is we actually, even there, already use the vector store to find RAG, to find the most relevant queries. But anyway, this is the description, this is the Sparkle query, and then again the visualization, right? So all of this, but everything you see in this thing is built by MCP. But let's have a look at that, how that works. So stop sharing, and now share Claude again. Sorry for the flipping around. You see Claude again, Janet?
Yes.
Okay, so now I can say, just for fun, looking at the above queries, can you create 3 more analytical queries that look good in visualization, right? And that's going to look at these queries. Let's see what kind of tools it's calling. Tools that are called thinking about analyzing existing queries to craft visualizations. And it's going to take a few seconds. Employee sales trends, it's now doing. So if I look at it, okay, so here are some queries. Okay, let's get the shackle to actually create these queries, right? So it got the shackle, mapping the schema properties for visualization queries. And now it's doing the Sparkle queries, right? So it says, okay, well, shipping performance analysis, employees, sales trend over time, category preferences by country. It's creating the Sparkle queries probably already. Yeah, you see here, it's already doing this. Sarah. Okay, let's make it a little bit simpler after this. Okay, let me do a simpler approach for the shipping performance query, right? And it's thinking again. It comes up with a new Sparkle query, trying it out. It's writing the query right now. Excellent. Now let me do a second query. I wish I'd asked for only one query. Sorry about that. But it's amazing, right? How it's writing these Sparkle queries. So you ask it to create stuff. Let's see. So it created yet another query here. Actually, pretty useful, and it showed the results in here. And then real soon, I should have asked for only one. Claude hit the maximum length for this conversation. Anyway, you get my point, right? After this, I can say, okay, please create a visualization for this. It creates a visualization. I can store it in my library, and I get all these beautiful visualizations that I just showed you in the browser. Sometimes there's too much here, but actually, this is a good point that you saw Claude hit the maximum length, because I need as an argument why we have specialized agents. I'll talk about that in a second. Okay, stop sharing. So this would be where my thing didn't run out. Okay, so I would say, can you create a visualization for query one that you just created? And then it says, okay, I can do this. And then it creates a query. Damn it. Okay, I'll leave that up. It's going to take too much time if I, well, one more time. It's there. Let me not touch any button. So what it also cool, it does a complete analysis of the picture that it created. So like January dominates as the strongest month overall, April exceptional strength, right? And then I get the heat map, and then I can ask the system, okay, now write it to the database, right? Okay, so this is about MCP, but it's important that you understood this MCP, because we're needing that MCPs everywhere in the accountable agent demo, right? So one of the things with MCP was that up to now, you only could use MCP from Claude. You couldn't use it in API calls, but just in October, they came out and now can use API. You can use MCP in API calls. So it's in beta. I actually wrote a version in Lisp that actually does that already. But let me talk about accountable agents. So when I try to explain it to people, I say, well, every decision is explained, every action is auditable, and every agent is accountable. That is kind of the tagline. Because there's an accountability crisis in AI, right? To begin with, we have black box AI, right? An LLM makes a decision, but why? An agent performs an action. Well, how did you do that? And the agent will say, well, trust me. Or the system fails, and then, hey, what happened, right? And it's a problem that happens in multiple domains, like in healthcare. Why did the AI recommend this treatment? Why? In finance, what data influenced this credit decision? And I could go on, right? And the other one, which is more important, is compounding errors, right? So, or error propagation in sequential agent chains. So in the agent demos that we built, we sometimes need 10 different agents to do work, right? Now, all these agents are LLM agents, meaning every agent makes mistakes, right? And just for fun, say that all these agents depend on the input of another agent. So if you then say have even a 1% error, right, in an agent, which is absolutely stunningly good, right? Then with 20 agents, you had 18% overall error rate, right? But say you just have 6, you already get up to 5, right? Now, if you have 5% errors in your LLM agent, then, and if you look at the benchmark, you see that hardly any LLM ever gets to 95%, right? Well, if you then just have 8 agents, you get 34% error, and at 20, you're already at 64, and 10% errors, and it's just catastrophic, right? So that's a huge problem that you have to deal with, right? And so that's why we say you need to record everything. So, but let me say that again in other words, right? So if you want to hold someone accountable, right, you have to be able to ask the question, so who did it? Which agent made the decision? Which agent gave you info? And who did you give it to? Or what did you actually do? What action was taken? Or when did you do it? And can you tell me why you did it? And what data did you use to get to this decision, right? So it's very important that you log every decision that you make and store it in the knowledge graph. Record the reasoning behind each decision and store it in the knowledge graph. Track all the data, document every action you take, and enable full audit trails after the fact, right? So that, now why is that important? Again, this is kind of common sense. Well, let me say it again. I'm a cognitive psychologist, right? And I know, because psychologists or cognitive psychologists write a lot about it, the only way you can change your behavior if your strategies, your tactics, and your operations, and learn from your mistake, if you can reflect on your own behavior and thinking, right? And if you just dump all your decisions and actions in a log, right, you get a 15 gigabyte log, and you can't do anything with it, right? It's very hard to get anything out. But if you are very systematic, ontological driven, and put all your data in a knowledge graph about every step your system of agents did, then suddenly you can reason over your own behavior, right? Very powerful. So how does a framework work? I kind of explained it already a little bit earlier. We have a specialist for every database. We know the ontology of the database. We store successful queries. We write tutorials for specific databases. And the orchestrator, and this is very important, the orchestrator knows the skill of it knows all the agents that are there, it knows the skills, and it has the ontology of every repository, so that the orchestrator, also an LLM, can figure out if you get a complex challenge, what task do I need to create, and what agent might I need, right? So how does this framework work, right? If this is a AllegroGraph, right, then we have a task creator and a synthesizer built into AllegroGraph, right? And so say you have a complex query, well, then the task creator in the knowledge graph gets a challenge, usually natural language. The challenge is broken in tasks, and they're recorded in the knowledge graph as open, unsolved. The specialized agents claim tasks, and it's recorded in the knowledge graph that the task is now being busy. Now, some people in the audience, over, I would say 50, might remember Blackboard systems, right? Where you had systems where tasks were broken down as subtasks. They were all posted on the Blackboard. Agents, or daemons we call them, would look at it, would take one or multiple tasks from the Blackboard, would reason about it, and would put the results back on the blackboard, and then other daemons might say, oh, there's something I can do with together with that one. It's almost like a forward chaining production system, if that means anything to you, right? Anyway, this is just how this works in our system, right? So you claim tasks, you solve tasks, but the problem is, in many cases, you just can't take a task and solve it. You actually have to get the results from other agents before you can finish your particular task, right? So there's dependencies between these agents. And if you have dependencies, you get race conditions. So you also have to deal with race conditions. And then finally, when everything is done, they have the synthesizer agent that summarizes all the task results and will tell you. So scenario in my demo is that you're a big company and you have an AI department, and one of your customers is TechCore, and TechCore Solutions escalated a critical emergency with their computer vision project, which is failing to meet contractual quality benchmarks and threatening contract cancellation. They're blaming technical execution, project management, but we don't know why. Right? It could be team competency gaps, resource allocation issues, supply chain problems, infrastructure, etc., etc. So the issue is, why did it happen and how can we fix it, right? And the orchestrator in this demo creates 6 tasks based on 6 available repositories. 6 specialized agents will solve the task, and then the synthesizer will present the solution. And so here are the databases. And again, I'm going way too deep here, but we have an HR analytics database, right, with employee data, skills, performance, and project assignments. And for solving the crisis, right, we find 5 employees with AI project experience, and we see that Sarah Chen is the lead on this project. But we also find that Sarah is actually doing way too many tasks. So that's one of the problems we'll find out. Then there's a customer intelligence database for customer relationship satisfaction, account management, contracts. And we find that TechCorp is really mad. They give us only a 2.1 out of 5 rating. They have a contract with us for $2.5 million, and it's managed by Sarah, who's already doing way too many things anyway, right? So there's a quality benchmark failing. And that is in another database, right? Production analysis, analytics, where we have production lines, work orders, quality metrics. And there we find that there's like 15% defect rate, right? Whereas you usually would like less than 5%. And the quality tests are not that good either, right? But then what you also want to look at is product engineering, right? Where you look at the product design, the bill of material, the component specs, the engineering changes, right? And again, we see the test results are doing doing really good, and there's all these engineering change orders that we need. Anyway, there's a particular lens. This is the problem. I'm going way too deep, guys. I apologize, right? And then we have a database with the supply chain, with suppliers purchase order, also part of the problem. And finally, there's inventory management, right? But note again, each of these databases could be SQL, MongoDB, another Elasticsearch, or a graph, right? It doesn't matter. The MCP agents know how to deal with their specific database, specific repositories. And then ultimately, in order to get the final answer and the root cause, low quality, defective components, failed quality test, customer escalation, by kind of traversing all these different databases with the different agents that all talk to each other, right? And so I have a demo, but it's actually, it's too complicated for a meeting like this. On the left-hand side, here you see, I make a little video here, sorry for the, so we have a dashboard so you can see what agents are working at a particular point in time. And then we start on the left-hand side. We start the track for a particular problem-solving episode doing the problem challenge that I just showed to you in natural language, right? And now it's starting by adding tasks to the system. So there's 6 local tasks, 6 active agents. They're all waiting to be picked up. These tasks, they're blue. At some point, they will get picked up and they all turn into orange. And then this whole system will start working. And on the left-hand side, for people interested, I can do a much deeper demo later where we go literally through the trace to see how one agent talks to the other, what we store in the database. And at some point, let's stop when I just get one successful task. But what you see here on the left-hand side, if you read fast enough, that Claude does a lot of work. So all the agents that we have, by the way, are Claude agents, right? That have MCP capabilities. And yeah, I still have to find a way to, and okay, now the root cause synthesis is already getting some results. You see on the left-hand side, lots of Sparkle queries getting generated in the process, dependencies. And you know what, given the time, I'll just switch off. But anyway, this is a running, all I want to show here, this is a running system that you actually can play with. Let me go to the next one here. Oops. So again, every action, creating a task, claiming a task, solving a task, putting the results of the task best in the database, needing and using the information from one agent to another agent is all added into the knowledge graph to get a complete problem-solving trail, right? And we store lots of things, like we store the task execution, this is Turtle, into the database, so we know what tasks were done. Every LLM interaction, so every time Claude reaches out to a database or anything using MCP, it will tell you what it was asking and the result it got back, all the data access, the Sparkle queries, SQL queries, no SQL queries go in the database. And every time the agents collaborate, it goes into the database, right? And then ultimately, when you're done, you could look in Graph, the visualization tool in AllegroGraph, right? And you see ultimately the tasks that were created, the agents that picked up the tasks, and then the collaboration events between the various tasks. And I could make this picture so much more complicated and better, but for now, I just want to give you a impressionist vision of how this all fits together, right? And then we can do accountability queries, like show me everything that the customer analyst did, right? So if you want to look at the trail, so you can look here and it will give you, so this asks for things that the customer analyst did, and it will tell you all the steps in the process, right? That it needed to do this task. Or who accessed the customer data, right? Say you want to do this for compliance. Well, that's also a query we can do where you get these results. And if you want to know how many tokens you use for each step, it's even that is in the knowledge graph. And these use cases you can do in many different situations, right? You can use it for regular compliance. So if you want a GDPR, you have a right to explanation of automated decisions. Well, you can find the whole decision chain for something that happened for you. If you're an engineer, you can debug your AI failures. If a customer doesn't agree, you can say, why was I denied? And you get the reasoning. Anyway, again, I'm going way too deep here. But why is it important to do accountability, right? So if you look at feature tracing, right, in a traditional multi-agent system, you hope that the logs exist. In our system, every decision is tracked. We can look at the reasoning chain. It's usually lost in code because it's all in code, but we store it in the graph. Data lineages, you have to do manual tracking. You have to code why something is tracked in the database. For us, it's just automatic. If you want to audit the query, you don't have to go through a log. You can do Sparkle in milliseconds, and then you can, the compliance is built in. Debugging is minutes instead of wait days or a week why something went wrong. And we can see the reasoning. Anyway, I hope I kind of convinced you here. And then finally, why does this have to be in a semantic or RDF knowledge graph, right? Why can't it be in SQL or in a property graph? Well, to begin with, the whole accountability trail is a graph, right? I just showed that here with all the dependency between the tasks and the agents. And then, and here's the important part, we need ontologies to describe the schema in various databases, even for SQL and NoSQL. So even if you have a MongoDB database or SQL database, we will express the content of that database as an ontology because we need a common language to target data in all the various places. We don't care if it's a Mongo, we don't care if it's a SQL, right? As long as we have a common language, which in our case is using RDF and RDF ontologies to describe what's in these various databases. We also need ontologies to describe the capabilities and skills of the agents. If you want to find what agent you're going to use, well, you better have a shared language. And in this case, again, you have ontologies to describe that, to help you with that shared language. Also, if one agent wants to talk to another agent, you better have a common language that's again driven by ontologies, right? And you need to reason over agent actions. Well, how are you going to do this in a SQL database or a property graph? And then finally, all communication should be in JSON LD. It's absolute total madness that right now in all agent systems you have only JSON flying out, but not JSON with only two little additions. One is, okay, what is the type of this JSON object? And what is the identity of the JSON object? If you have that, if you add that to your JSON, everything becomes easier. And JSON LD is just the RDF version of JSON LD can be very easily just translated into RDF triples. And with that, my time is up. I have some other slides, but I think this is probably the best way to stop this my presentation. Right? And if you want to build a practical intelligent AI system yourself, send email to us.